Alright, we're going to do review worksheet 3.5, 3.6, part 2, which is 16 to however far I'm going to get in this video. Hopefully you don't need another part, but we might. This is all going to be using the same tips. Alright, so you're all going to be solving radical equations. So no matter what you see, the first thing you're going to have to do is you're going to have to isolate the radical. So you're always going to isolate the radical. If there's two radicals, they have to be on opposite sides. There is a case where one of the radicals cannot be isolated, and you have to square both sides twice, and those like 36 and 37. All right. Step 2: square and cube both sides. If you have a fraction exponent, you raise both sides to the reciprocal. Some people do like to change it to in radical form. You can do that, but it's a little bit more work. So I always raise both sides to the reciprocal. I just think that's easier. And then you solve the remaining equation. When you solve, you have a couple options. Option 1 is if you have one variable. That's when you're going to use PEMDAS backwards. All right. If you have multiple variables, you're going to factor and solve. That's more than likely. So you're going to set it equal to 0, do the factors of the first, factors of the last, then you're check the middle using FOIL. A lot of times we'll have that easy shortcut with the addition, but that only happens if you have a positive x squared. All right. So I would always keep your x squared positive. Remember, then once you do that, you set each number equal to 0, or each parentheses equal to 0, and then you solve that. Remember, you always have to check your work. If you do not check your work, there's a good chance you're going to mess everything up. So you must check your work. All right. You must show check step, because we might have extraneous solutions. So you must show your check step. Do not skip that or you're going to lose points, okay? So that's it. We're going to go right into number 16. So 16 is the square root of 5x plus 1 equals 16. All right, equals 6. Now, the radical is isolated. That's done. So I just square both sides to start. Now, the reason I know it's isolated is there's nobody outside of jail. So I have 5x plus 1 equals 36. I subtract 1 from both sides. I get 5x equals 35. Divide by 5. This is just PEMDAS backwards, guys. So I get x equals 7. Plug it into C. So I say the square root of 5 times 7 plus 1 equals 6. Is that true? I don't know if that's true. 5 times 7 is 35. Is the square root of 36 equal to 6? That is true. So that's my check step. Okay? And that's it for 16. Alright, so once again, this is all just like PEMDAS. You can also just use this as PEMDAS backwards as long as you pretend that multiplication is in parentheses. Right? It's kind of implied. So I see addition, that's why I subtract 11 from both sides. Or remember, we're isolating the radical. Right now there's somebody outside of jail, I gotta get rid of it. So I have square root of 9x equals 3. I square both sides to get rid of the radical. It's a square. So I get 9x equals 9. Now I look and see, I have multiplication. How do I get multiplication? Division. That's why I divide both sides by 9. I get x equals 1. I don't know if that's true yet. I have to check my work. So I say the square root of 9 times 1 plus 11. Does that equal, I don't know if that's true, 14. 9 times 1 is 9. So the square root of 9 is 3. 3 plus 11. Does that equal 14? It does. So that means that's a good answer. And that's it for 17. All right. So 18. Once again, I see these guys out of jail. Negative 2 is out of jail, 13 is out of jail. I get rid of addition before I get rid of multiplication. That's why I subtract 13 from both sides. So I get negative 2, square root of 24x equals negative 2. Now I have to get rid of the negative 2. Make sure you divide. All right? Negative 2, that's negative 2 times 24x. So if I do my PEMDAS backwards, how do I get rid of multiplication? By division. That's why you divide by negative 2. I get the square root of 24x equals positive 1. Square both sides. I get the square root, I get 24x equals 1. Divide by 24. Divide by 24. I get x equals 1 over 24. I would not leave that as a decimal. I would leave it as a fraction, 1/24, because it's not a pretty decimal. Now I got to check my work and see if it works. Negative 2 times the square root of 24 times 1/24 plus 13, does that equal 11? Well, 24 times 1/24 is 1, square root of 1 is 1, negative 2 times 1 is negative 2, plus 13 is 11. That works. So it's a good answer. That's it for 18. All right, in 18, I have the square root of x minus 25 plus 3 equals 5. First thing I do, let's subtract 3 from both sides. So I get square root of x plus x minus 25, equals 2. I square both sides. Get x minus 25 equals 4. I add 25 to both sides because that's how I get rid of the subtraction. I get x equals 29. Now I got to check my work. Does the square root of 29 minus 25 plus 3 equal 5? I don't know if that's true. 29 minus 25 is 4. Square root of 4 is 2. Is 2 plus 3 equal to 5? It is. That means that's a good answer. That's it. Alright, 20. I have negative 2 out of jail. I have to get rid of that first because I need to isolate the radical. So I get the square root of negative 2x plus 3 equals 12. Square both sides. I get negative 2x plus 3 equals 144. Now, I subtract 3 from both sides. I get negative 2x equals 141. Divide by negative 2. Divide by negative 2. I get x equals negative 70.5 or 141 over negative 2. One of those two. Okay? Plug it in. So I got to check my work to see if these work. Square root, I have negative 2 times, that's why I love it as a fraction, because this works out really nice. So 141 over negative 2 plus 3 minus 2, does that equal 10? Well, look, those cancel. 141 plus 3 is 144. 12 minus 2 is 10. It does work. So both of those are good. Doesn't matter which one how you write it. You could give me negative 70.5, or you could give me the fraction. It doesn't matter. That's it for 20. Alright, I have the cube root of x minus 10 equals negative 3. Once again, I have to isolate the radical, so I add 10 to both sides. I get the cube root of x equals 7. Now I have to cube both sides. Notice I have to cube both sides because it's a cube root. So I get x equals 343. Now I'm going to plug it in to check my work. The cube root of 343 minus 10, does that equal negative 3? Well, does 7 minus 10 equal negative 3? It does. So that's a good answer. That's it for 21. Alright, 22. I have the cube root of 12x minus 13 equals negative 7. I have to get rid of everything by the radical, so I add 13 to both sides. I get the cube root of 12x equals 6. I cube both sides. Remember, because it's a cube root, I have to cube both sides. 12x equals 216. Divide by 12, divide by 12. I get x equals 18. So now I'm going to plug this in. So I say the cube root of 12 times 18 minus 13 equals negative 7. 12 times 18 is 216. The cube root of that is 6. 6 minus 13, does that equal negative 7? It does. So that's it for 22. Alright, 23. We have negative 5 times the cube root of 8x plus 12 minus 8. So once again, I have to get rid of everything around the radical. I always get rid of addition first. So I say negative 5 cube root of 8x equals minus 20. Now I divide by negative 5. Divide by negative 5. I get 8x inside the cube root equals positive 4. I cube both sides right now. 8x equals 64. I divide by 8. Divide by 8. I get x equals 8. Now I have to check it. Negative 5 times the cube root of 8 times 8 plus 12. Does that equal negative 8? I don't know if that's true. 8 times 8 is 64. Cube root of 64 is 4, so I get negative 20 plus 12. Does that equal negative 8? It does, so that's a good answer. That's it for 23. Notice we haven't got any extraneous solutions yet. A lot of times you don't have extraneous solutions unless you have to end up factoring and solving. So you're good on up to 23 with extraneous solutions. Alright, 24. We have the cube root of x minus 3 plus 2 equals 4. Same concept. I'm going to get rid of the addition first. I have the cube root of x minus 3 equals 2. I cube both sides. I get x minus 3 equals 8. I add 3 to both sides. I'm sorry. Yep, that's right. I add 3 to both sides. I get x is equal to 11. Let's check it. So I have the cube root of 11 minus 3 plus 2. Does that equal 4? Well, 11 minus 3 is 8. Cube root of that is 2. Does 2 plus 2 equal 4? It does. So this works. It's good for 24. All right, so 25, we have negative 4 times the cube root of x plus 10 plus 3 equals 15. Notice, guys, in all these problems, I've been really careful about when I write the radical exactly the way it looks like in the problem. Sometimes people get in the bad habit of making their bar go on like forever, and that really messes up everything. So you got to make sure you're really careful with that. The 3 is out of jail, that's why I get rid of it first. So I get negative 4 times the cube root of x plus 10 equals 12. Now I divide by negative 4. I get the cube root of x plus 10 equals negative 3. I cube both sides, so I get x plus 10 equals minus 27, minus 10 from both sides, minus 10 from both sides. I get x equals negative 37. Now I got to plug that in and see if it works. So I say negative 4 cube root of negative 37 plus 10 plus 3. Does that equal positive 15? So I have negative 4 times, that's negative 27, so it's negative 3 plus 3. Does that equal, negative 4 times negative 3 is positive 12. Positive 12 plus 3 does equal 15. It's good. So that's a good answer. That's it for 25. All right, so 26, once again, just PEMDAS backwards. This time it has a fraction exponent. So remember, if you have a fraction exponent, you raise it, that's not multiplication, so this is an exponent, to the reciprocal. Now you can only do that once it's by itself, so I have to, so you go, there's no subtraction, there's no addition, there's no division, there's multiplication. So you have to get rid of the 2 first. You get x to the 2/3 equals 16. Now if that was in parentheses, which it's not, then you would have to get rid of the exponent first. So now I'm going to add 3/2 up there. So when you put it in your calculator, you have to put 16 caret 3 ABC 2. All right, you cannot use multiplication. It has those cancel. You get x equals is 64. So now I got to plug it in. So I say 2 times 64 to the 2/3. Does that equal 32? Well, 64 to the 2/3 is 16. 16 times 2 is 32, so that works. That's a good answer. And it's good for 26. All right, 9x to the 2/5 equals 36. So once again, PEMDAS backwards. Somebody's going to try to get rid of the exponent first. There is no subtraction, no addition, no division. You have to get rid of that multiplication first. So you get x to the 2/5 equals 4. Now you can take it both sides to the 5/2. Okay? So those cancel. You end up with x equals, because this is even, you got to put plus or minus there. Okay? So when I plug that in, I get 32. So because it's even, it is plus or minus. Now I just got to check my work. So I said 9 times 32 to the 2/5 equals 36. 32 to the 2/5 is 4. 4 times 9 is 36, so it's good. And a good answer. Okay? Now we're moving on. Alright, so I'm doing PEMDAS backwards. Remember, you can always use PEMDAS backwards. There's no subtraction, there's addition, but it's inside the parentheses. There's no division, depending on how you look at the fraction. A lot of you guys think of it as multiplication, so I'm going to divide by 1/7. You could multiply both sides by 7 as well, that's an option. Divide by 1/7, those cancel. I get x plus 9 to the 3/2 equals 343. Now I'm going to take both sides to the 2/3 power. Alright, so I take both things to the 2/3 because remember that's the reciprocal. I get x plus 9 equals 49. Now I have to subtract 9 from both sides. So I get x equals 40. Now I got to check my work. So I say 1/7, 40 plus 9. to the 3/2, does that equal 49? 40 plus 9 to the 3/2 is 349. 1/7 times 343 is 49, so that's a good answer. That's it for 28. All right, 29. I do my pendants backwards, and what I find out, when I look at pendants backwards, I see subtraction, but remember, that's in the parentheses. There's no addition, there's no division. I see multiplication, that's in parentheses. So I have to get rid of the exponent first. So I flip 1/2, and that's just 2. So I square both sides. I get 1/3 x minus 11 equals 25. I add 11 to both sides. Because I'm doing pendants backwards, I get 1/3 x equals 36. Multiply both sides by 3, I get x equals 108. Now I just have to plug it in, so I say 1/3 times 108 minus 11 inside parentheses. Does the square root of that equal 5? Or does that to the 1/2 power? Remember, those are the same thing. 1/3 times 108 is 36. 36 minus 11 is 36 minus 11 to the 1/2. 5? It is. So 108 is a good answer. Right? And that's it for 29. All right, number 30. We have 3x plus 43 to the 2/3 plus 22 equals 38. So once again, I got to get rid of the additions. That's why I subtract 22 from both sides first. I get 3x plus 43 equals, to the 2/3 equals 16. So now I have to take both sides to the 3/2. So I get 3x plus 43 equals plus or minus, because that's even, 64. So now, remember that's two answers, so I have 3x plus 43 equals 64, and 3x minus plus 43 equals negative 64. I minus 43 from both sides. I get 3x equals 21, so I get x equals 7. Most of us are going to get 7. Most of us aren't going to get this next answer because we're going to forget about the plus or minus. So we get 3x equals negative 107, divide by 3, divide by 3. X equals negative 107 over 3. Plug them both in. They both work. So don't forget to show your check step. And that's it for 30. All right, so 31. X minus 10 equals the square root of 9x. The radical is isolated, so I got to square both sides. Since there's a minus sign in the middle, I have to FOIL the left side. I cannot just square x and square 10. A lot of people are going to make that mistake. So when I FOIL the left side, I get x squared minus 20x plus 100 equals 9x. Now I have to minus 9x from both sides. I get x squared minus 29x plus 100 equals 0. Now I have to factor. So I had to set it equal to 0. That's the first part of factor. Now I got to factor. So I get the factors of the first term, that's x and x. How do I get 100? Well, how about minus 25 and minus 4? Because they will multiply to give me positive 100, but they'll add to give me negative 29. So I say x minus 25, x minus 4 equals 0. Now remember, the shortcut is you just change the sign, but remember, x minus 25 equals 0. That's why x equals 25. X minus 4 equals 0. That's why x equals 4 when you add 4 to both sides. So there's your answers. Now I have to plug them in because they both might not work. So I'm going to plug in 25. 25 minus 10. Is that equal to the square root of 9 times 25? Well, 25 minus 10 is 15. 9 times 25 is the square root of 225. And that's a true statement. So x equals 25 is a good answer. Now I got to try 4. 4 minus 10 equals the square root of 9 times 4. Is negative 6 equal to the square root of 36? That's not true. So I cross that one off and I write extra, which tells me it's an extraneous solution. That means you did all the math right. You should have got 4 as an answer, but it's not a good answer. And that's why it doesn't work. All right, so the radical is isolated on the left. That's why I squared both sides to start. Now the left side's easy, 21x plus 1. But the right side, because of the plus sign, because of that plus sign, you have to FOIL. So if you don't FOIL, you're making a mistake. So I get 21x plus 1 equals x squared plus 10x plus 25. Now I'm going to set it equal to 0. I like to keep my x squared positive, so I'm going to move 21x over. I'm going to move 1 over. So minus 21x minus 1. I get x squared minus 11x plus 24 equals 0. Remember, how do you get x squared? X and x. I'm going to say minus 8 and minus 3 because that will give me the minus 11. So I'm left with x minus 8. X minus 3 equals 0. So x is equal to positive 8. X equals positive 3. So now I have to check both answers. I don't know which one's going to work. I have to check and find out. So I plug it in. I say 21 times 8 all over underneath the radical plus 1. Does that equal to 21 plus 5 underneath the radical? Or not underneath the radical. Just equal to 21 plus 5. So the right side's easy. That's just 26. So I put the left side inside my calculator. 21 times 8. 20 times 8 is 160. So it's 168. So we have 169. So the square root of 169, which is 13. Oh, this is supposed to be 8, not 21. I don't know where I got 21 from. 8 plus 5. Does it equal 13? Yes, that one does work. So that works. Now we try 3. 21 times 3. So I square 21 times 3 plus 1, all underneath the radical. Does that equal 3 plus 5? 21 times 3 is 62. 63 plus 1 is 64. Is the square root of 64 equal to 8? Yeah. So in this case, we have 2 good answers. There are no extraneous solutions for number 32. That's it. All right, 33. Square both sides to start. Left side's easy. It's just x squared plus 4. Right side, you have to FOIL, so I end up with x squared plus 10x plus 25. I'm going to subtract x squared from both sides. It's going to work out pretty nicely. So I end up with 4 equals 10x plus 25. I'm going to subtract 4, or I'm not going to do that. I'm going to subtract 25 from both sides. I get minus 21 equals 10x. Divide by 10, divide by 10. I get x equals negative 21 over 10. Or maybe you have negative 2.1. Either or. Maybe you have negative 2 and a tenth. Either or. Those are all acceptable answers. So now you have to plug it in and see if it works. So I do negative 20. So I do negative 21 over 10 squared plus 4. Does that equal negative 21 over 10 plus 5? Now when you plug it in your calculator, the left side turns into 2.9. The right side turns into 2.9. So they both work. So this is a good answer. And that's it for 33. All right, 34. I see the fourth root. So this time, instead of cubing it, I have to take both sides to the fourth power. Remember, you take the 2 and the x to the fourth power. So this turns into 3 minus 8x squared equals 16x to the fourth. Now I'm going to set it equal to 0. So nothing's going to change. I'm still going to factor. So I'm going to minus 3. I'm going to add 8x squared to both sides. So I get 16x to the fourth plus 8x squared minus 3 equals 0. I just moved everything to the right side, and then I wrote the right side first. You're allowed to do that. I'm going to use 4x squared and 4x squared because that's going to work as long as I use positive 3 and negative 1. So this gives me 4x squared minus 3, 4x squared plus 1 equals 0. So I set them both equal to 0. I say 4x squared minus 3 equals 0. 4x squared plus 1 equals 0. I add 3 to both sides. This should be plus 3 and negative 1. I messed up. So I minus 3 from both sides. So I get 4x squared equals negative 3, divide by 4, divide by 4. I get x squared equals negative 3/4. When I take the square root of that, it's domain error. So that's not going to help me. Okay? That's why you don't have to worry about this one. Now I minus 1 from both. So in case you didn't understand, I messed up here. So this should have been plus 3. This should have been minus 1, which makes this minus 1. So I add 1 to both sides. I get 4x squared equals 1. Divide by 4. I get 1/4. I square root both sides. Then I get x equals plus or minus positive 1/2 or negative 1/2. When I plug them in, negative 1/2 is extraneous. So 1/2 positive is your good answer. Okay? You have to show me your own check step. I'm running out of time, so I'm not going to do the check step. 35. I have two radicals. So they have to be on opposite sides. They are on opposite sides. So that means they're isolated. So that's why I square both sides to start. It makes them both sides are easy. So I get 4x plus 1 equals x plus 10. I'm just going to put my x's together first. So I get 3x plus 1 equals 10. Now it's just PEMDAS backwards. Minus 1 minus 1. 3x equals 9. Divide by 3. Divide by 3. X equals 3. Plug it in. The square root of 4 times 3 plus 1, is that equal to the square root of 3 plus 10? I get the square root of 13. Is that equal to the square root of 13? That's true. So even though I get messy stuff if I plug in my calculator, it still works out pretty nicely. That's it for 35. All right, 36 is long. I'm trying to get through it before the time runs out. So I have 3x minus 8 plus 1 equals the square root of x plus 5. I square both sides. Even though that plus 1's out of jail, it can never make the radical. If I subtract it from both sides, it would never make either side isolated. So I just got to deal with it. So I have one easy side, I have one hard side. This is just x plus 5. I have to FOIL the left side. So 3x minus 8 plus 1 with square root of 3x minus 8 plus 1. I FOIL it. FOIL, I get the radicals cancel, so I get 3x minus 8. I do the inside, I get times 1 plus 1 square root of 3x minus 8 plus 1 square root of 3x minus 8. And then I do the outside, I get plus 1. These combine, it gives me 2 square roots of 3x minus 8. Combine my like terms, so I get plus 3x minus 8 and plus 1 is minus 7. Now I have to set it equal to 0. That's why I got a minus 3x. I have to simplify. I have to get the radical isolated. That's why minus 3x and add 7. So I minus 3x and I add 7. So I get 2 square root of 3x minus 8 equals negative 2x plus 12. Divide everything by 2. So I get square root of 3x minus 8 equals negative x plus 6. Now that I have the radical isolated, I square both sides. So I get 3x minus 8 equals x squared minus 12x plus 36 after FOIL. Make sure you FOIL there. I set equal to 0. I get x squared minus 15x plus 44 equals 0. 4 and 11 work, so I get x minus 4, x minus 11. So x is equal to positive 4, x is equal to positive 11. Once I check my work, I find out 4 is a good answer, and 11 is extraneous. All right, you have to show the check step. I know that was really quick, so go through that step by step. I squared it once, simplified it. I had to isolate the radical, and I had to square it again. I had to set it equal to 0. That was pretty quick, so if you have any questions, come see me. And that's it. I'm not going to be able to do 37. Let me know if you have any questions on either of the 37s. Alright, so I got up to 37 on the video, or I'm sorry, not 37, 36. There was one mistake on purpose, so if you have any questions on that, let me know. It's a really tiny mistake too. Alright, and that's it.